We are beginning the afternoon session of today, and Professor Daniele Mundici will continue his course, presenting us the second part of the course. Possiamo cominciare, professore.
Okay, have a good day, question. The title of my course is this, and we start with a brief summary of the last but one lecture. We started from everyday life, any computer, any day, any night, everywhere in the world, because wherever they play football, or everywhere where they have horse races, or everywhere where they have insurances, or everywhere where they bet on something. You have this sort of things with numbers that are not probability, but are inverse probability. They are designed to confound for people who put money, giving them the illusion of multiplication of their hopes. But if you take the inverses of this number, so how much you have to pay to win 1 real, this is the probability. You take the inverse, you discover inconsistency, which you will remember, I will not repeat. We took the inverses and we showed and we computed that the sum of these incompatible, exhaustive events is not 1. It's not less than 1. It is more than 1. And then suddenly we pass to the first, in my opinion, that in the history of Western thought and developed the idea that logic and probability, whatever it is, are the two faces of the same coin. He explicitly stated the object of probability. Given probabilities of some events, E1, E2, En, compute a possible probability of a new event. This is what every day we do. We know the probability of something we already know, and we hope, and we implicitly compute on the basis of this knowledge the probability of some new event. This is almost sure, this is almost not sure, and so on, and so on. And then the object of logic, the particular case where the events E1, E2, En are given probabilities. No, now they are called truth values in 0 or 1. The difference is minimal, and the object is the same. Compute the possible truth values of a new proposition, event, statement. And then we introduce definitive, quantitative, operational, non-explosive definition of inconsistency as the situation where a shrewd, clever, intelligent bettor, which we name Betty, a fox, can, by suitably buying or selling tickets in the lottery of bookie, holy bookie, because bookie accepts to buy his own tickets, signed by Betty. The situation where Betty, by a shrewd choice of what to buy, what to sell of the tickets in bookie's lottery, can send him bust, to ruin, to bankruptcy. I will buy 1 zillion tickets of this, I will sell 1 zillion tickets of that, I will sell 2 zillion tickets of that. Of course, this is mathematics. No bookmaker accepts infinite stakes. Sometimes when they see there is something suspect, that people say from Rome, bet billions on a football match, they block. Well, of course, bookmakers are not stupid. In fact, we met a classical bookmaker who said, your inconsistency are my money. The ticket is something I would like you to memorize. It is a very simple thing. Bookie has posted, has written in his blackboard, or has put in the internet, as we have seen, his betting odds. And the betting odd of an event is the price you pay now in the hope of winning 1 unit, €1, 1 real, $1, if the event occurs. So now you pay less, but you pay. And if the event occurs, you get 1. Multiply by any amount. You want 1 million, you pay now 1 million multiplied by the probability, which is usually less than 1, otherwise. Okay? But we know that even Betty can write, well, can sign these books and sell them to Bookie, who, being a holy Bookie, buys. Well, this is the only irrealistic. There are many others, the fact that one bet any amount of money and so on and so on. But this is the most unrealistic thing with respect to the behavior of real bookmakers. But it's very useful mathematically. And you know, mathematicians don't live in the common world. They don't digest. And so they like this, definitely like this. He was a man in insurance, so he made money, blah, 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 and they had this beautiful irrealistic mathematics, which helps us to understand inconsistency. Now, the most important thing is the accounting, the balance of a bet. Bets are oriented always from the bettor to the bookie, as usual. There is an orientation. When they teach you the straight line, they show you a straight line, they put a point and say, this is 0. They put you another point and say, this is 1 unit, and then they give an orientation. Even here, money travels with an orientation. When it is negative, it is money that travels from bookie to the bettor, okay? Very rare situation, but negative bets, negative stakes. Negative stakes is the bookie buys. Negative money that it goes to betting. So a book, very down-to-earth term, assigns values in the unit interval to the events. This is a book. And Betty buys or sells positive or negative tickets from the lottery of Mr. Bookie. So NI is, if it is positive, it is Betty who buys. If it is negative direction, it is Betty that sells. Okay, you remember this because it is the structure of the rest of the theorem. And so the balance is multiplied by the stake, positive or negative, the difference between what you pay now and what you get if the event occurs. If the event occurs means in the possible word, whether the possible word says yes, it has occurred, or no, it has not occurred. It is the truth value. Oh, yes, wrong. Be patient. I never point out because it's not right technique. Anyway, and inconsistency is now defined. A book. So, book is book, beta. On events, is inconsistent if Betty can devise, calculate stakes and 1 and k to sell or to buy such that in any possible world, so sure, bookie gets lost, gets less than 0. What does it mean, less than 0? Well, if it is zillion, it is less than 0. Zillion, you are afraid it could be 5 zillion, okay? Less than 0 is ruin. In fact, you could put less than 1 or less than 1 zillion euros reactions. And you know, real classical, honest bookmakers make money because they say that what we call inconsistent, so wrong book, is exactly what is used by them to make money. Because there are people who buy and don't sell, of course. And then I hinted about the handouts, completely different style. Those of you who have seen them, thank God, I didn't want to read this stuff. The slides, the handouts is written in a different style, classical mathematical style, but it is oriented to lower undergraduate mathematics students. So if you know what a Boolean algebra is, if you know what a homomorphism is, if you know what a derivative, first order derivative, sometimes it's used, is, if you know what a convex set in Euclidean space is, then you can read the handouts. Otherwise, you can write to me, and I will tell you what is a convex set, because it's easy, and it is in the handouts, okay? End of the summary of the first lecture. Having been so criticized by a real bookmaker, holy bookmaker says, why is my quest, my search, my mission for consistency is it of any use to anybody, mostly to logicians? Why? In which sense what I'm doing, accepting to buy instead of only selling, how is it useful to logicians? And now remembering you asked what does it mean to extend? And others, and I told you Jesuitically. I didn't even define event, you remember. So if you have a minimum of mathematical, let's say, feeling, and you have, I'm sure, because if I say 2 + 2 = 5, you say, well, let's see, okay? It's not. Now here, I said event, I said possible words, whatever the case, and it was not defined. And it's not good to teach at this level, which is also precise, it's scientific level. This is a Sao Paulo school. It's good to be precise when you define things. And here are the 2 things, or if you have other things that I didn't define, please say. Mundici, you didn't define better. You didn't define Betty. And then I well, okay, no, don't raise your hand about defining a fox. I'm not a zoologist. You all hence should protest, because for almost 1 hour and 3/4, I did not define events, and I started gesticulating, hand waving. This is the way mathematics can be done, by hand waving about events and so on. I'm sure I have convinced you that probability is between 0 and 1, because otherwise you buy or sell. I gave the example. If it is negative, you buy, so you get money, and then you will get more money again. If it is above 1, you sell, you get money by selling, and you will at most pay less than what you got. So that's the reason. The definition has half a page on this. It's very wise. Probability is 0, 1 because of Definity's definition of inconsistency. So I'm sure I convinced you that probability must be there, that incompatible event should be blah, 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 but with hand waving, and I'm sure Fernando agrees with me, with hand waving, you don't go deep in science. Now, if you read 16th century medicine books, you find horrible things. Hand waving about what is any sort of disease They write things which are horrible. They are absolutely false, mad. They are doctors that probably made a lot of money with kings and princesses and so on. But it's not only hand-waving, it's killing the patient, okay? If we don't look for precision and strive for precision as much as possible, we cannot go as deep as we would like to go. And everybody of you would like to be deep, to say things that persist, that can be communicated in any language, in any nation. And okay? That's why I'm here again. You see, Fernando obliged me to rewrite my course. I told you, I started in 2020, then COVID, blah, 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 and then Fernando, and I'm rewriting it. Look, the translation of Goethe is different from Fernando's. That means that I had it before, because I wanted to give you this beautiful translation against mathematicians and against French people. And not against mathematicians, of course. The mathematician, me, is like a Frenchman, though he's Italian, maybe. It translates things in his own, her own language, and this beautiful adverb, and forthwith, which was not in Fernando's translation, and from there on, and after that, and any instant after that, nobody understands anything. Goethe was polite. It is something entirely different. But it means that after the mathematician takes this notion in his hands and speaks about it, you admire what he said, but you don't understand anything. Might have to, Fernando. Adapt to soccer. Entering a straight leg, entrata a gamba tesa, no sé en portugués. And castellano, entrata a gamba tesa, and soccer, means, well, you can fracture your opponent's leg. And this happens. You are immediately expelled. Cardone, no? Red card, immediately, because it's so dangerous. That's why I put this picture, because now I'm writing 2 lines of hard mathematics, French style. How will you react? Your legs will be fractured? Well, close your eyes. Events, and then I will explain, but I'm just entering a straight leg. Events are elements of a Boolean algebra. Which one? Well, depends on the context of the problem. Second, the expression. Whatever the outcome, in any case, whatever, in any possible world, means for all homomorphisms of the algebra into yes-no, which is a Boolean algebra, you know. There is the minimum between 0 and 1, there is a maximum, there is flop, 1 minus. So possible words are homomorphism of your Boolean algebra of events into yes-no, 0, 1. Copy that, vomit on this, or fracture it, but no, don't vomit because we have eaten very well at the hotel. Accept it, even if you never heard of Boolean algebra. But we had here sophisticated, super learned talks about not even Boolean algebra given for free here. So events are elements of Boolean algebra, the homomorphism are homomorphism into yes, no, 0, 1, the truth values. Are you joking, DM? How can we understand this abrupt reformulation? It was better when you were hand-waving, in a sense. Why algebras? Why homomorphism? And here again, well, Fernando insisted on the role of algebra, homomorphism, and then ideals, prime ideal sheaves, in the development of mathematics in the 17th, 18th, 19th century, and today they are common ground. So we will need the help of Holy Bookie, the help of Foxy, and the help of this new girl who meditates when things seem to be too hard for you. There is this girl telling you must meditate if you wish to understand. Okay? It's not a matter of meditation for months. It's a matter of meditation usually for a few minutes or a few seconds. But this girl will point out that you need to meditate a little bit more than what I'm saying. It happens, of course. Any teacher expects that students, you're not students, you are professors and researchers, much more alive than me. Anyone expects that anyway you meditate. I want to explain why events are elements of Boolean algebra rather than statements in the air or news in the newspapers printed and there that you read. No. Look at this situation. In June, the economy will collapse, just to keep we alive. Okay? I'm happy. The second statement is the world economy will collapse after May and before July. And the two truth values assigned by Holy Bookie are not the same. Point 2 and point 3. You are Foxy, or let's see what Foxy does. It is written here. The same event, written in two different ways. Logically equivalent way for you see, two propositions, two statements which are the same. In which sense the same? This is a very deep question. In the sense of some logical equivalence, which is an equivalence relation that allows you, mathematicians say, to mod out, to take a quotient, to see things modulo this equivalence. This is fundamental, like see things modulo a subset or modulo an extension. Modding out. The same event with two probabilities, it could happen, but leads Bookie to disaster. Why? Because Foxy buys the cheaper event and sells the more expensive event. What happens? Whatever happens, she gets the difference between the two, or she gets even more money. Try to compute it. Okay? Clear? If you write the same event in two equivalent ways and give different probabilities to the same event, written in two different ways, you will lose your activity as a bookie immediately. So this shows that betting odds are really assigned not to statements, not to formulas, but in essence to equivalence classes of, which means elements, not in the Montarski, elements of Boolean algebras. That's why Boolean algebras can note they afford an enormous simplification in the situation. Rather than evaluating formulas, we are evaluating equivalence classes of formulas, which have a much richer structure than the structure of the formulas. The formulas form the absolutely free algebra formulas. It's a syntactic algebra, very beautiful. The computer likes it, but human mind prefers modding out to Boolean algebra. Okay? What is a Boolean algebra? Is the formulas modulo logical equivalence relation in a given context. Forget about details. We are passing from syntactic objects where the computer computes to algebraic objects. If you have questions, please feel free to ask. I can answer. I don't know if I will. Anyway, if something is not clear, and at the beginning of this course, I would like to be very clear. I introduce deep notion, algebra and homomorphism. And then Mr. Goethe, we are prepared for the worst. Now, mathematician has started to speak French, and what happens now? In fact, what is a logical equivalence class of statements? I told you it is statements are operated by an equivalence class. This statement is equivalent to that statement. You remember, failure of economy in May is the same as failure of economy, blah, 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 blah. So he asks, and we reply. Events can occur or not occur. Events are closed under negation. The negation of an event is the event that doesn't happen in any possible world. If the event, any possible world, we'll come to it. The negation of an event is the opposite of the event. It's clear to you. Let me do some handwave, okay? And events are closed under conjunction. For any two events, there is their conjunction. They happen both, wherever you are, in any possible world. We'll come to that. Events are elements of a Boolean algebra, capital A. Events are coded by newspaper statement, by formulas in a logic, by whatever you like, by music, if you code events musically, okay. But events are elements of an algebra. In essence, equivalent formulas code the same event. So you see, we have a notion which is a quotient of another, perhaps easier notion, what I read, but it is the quotient which is the notion to work with. Look at this, again, about Rio and Copacabana and so on. Tomorrow at Rio will rain at 10. Tomorrow at Rio will not rain at 10. These two events are incompatible. In which sense? In the sense that whatever happens tomorrow, in any possible world, for any event, they cannot happen simultaneously. Here in this course we had learned people who spoke that there are many negations. I heard many talk. This is the down to the Boolean negation about events subject to yes, no. So we are doing the simplest possible events. For any event, there is this companion that happens exactly when the event doesn't happen. Okay? So classical negation. We'll go to other negations later on after we have mastered inconsistency. But first we must understand Boolean negation. And prepare for the worst. Goethe asks, what is a possible world? It is not an arbitrary situation whereby, by means of which an event gets yes or no. Because a possible world is a possible world. It must respect the structure of the event. So if an event in that possible world gets yes, its negation in that possible world gets no. So events are not functions. They are special functions that take into account the structure of the Boolean algebra. Here is the answer. For any possible world, fix a possible world. This one, this is a possible world. For any event, the possible world gives value 0 or 1, according as the event happens or not, occurs or not. The negation of an event gets the opposite truth value in any possible world. And the conjunction gets what? The minimum of the two truth values. You know this. If here I drink water gets 1 and you drink water gets 0, the conjunction of the two events is an event and gets 0. Clear? So, W, possible word, here the French speaker, chaque bon possible is a homomorphism of the algebra into 0, 1. For this reason, it must respect the algebraic structure. A homomorphism is something that sends the rich algebraic structure, which is richer than the structure of the formulas, by the way, sends it into some poor structure, the structure of truth values. but does it respecting the structure of the algebra. So homomorphism is, if you wish, a simplification. You have many possible words, as this picture shows. So the expression, at last, whatever the outcome means in any possible world, it est for any homomorphism of the algebra. Well, at least events and possible words have been defined, French style. Please, God bless. This symbol is for you to either I know this or copy and bring home this. Whatever the outcome, in any case, means for every homomorphism. Events, I repeat, repetita iuvant. The logic I will present is fundamentally insisting on the repetita iuvant. In training, yeah, in Copacabana at 10 o'clock. I should have changed it to Campinas at 2. Events are elements of a Boolean algebra. The expression, whatever the outcome means for every homomorphism of the algebra. Into 0, 1. Hom A is the set, it's a set. No, it's the set of all. If the Boolean algebra is finite, there is a finite number. Okay. It's the set of all homomorphism of the algebra into 0, 1, which is a Boolean algebra, the prototypical Boolean algebra. And Boolean algebras, so, are formulas modulo up to, divided by, thought about modulo and equivalence relation, logical equivalence. So this is a summary of the mathematization of what I did in the first lecture. No entering with straight line, I hope. Okay, this is fundamental. Methodological remark. Indebted to Fernando. Algebras and their homomorphisms are not introduced to intimidate you. Rather, they are introduced by trial and error, by effort, year after year, century after century, to better understand the reality. For instance, the reality of probability, the reality of betting, the reality of money, the reality of financial transactions, the reality of artificial intelligence, the many realities of artificial intelligence. Without a working knowledge of these elementary artifacts, you can't do philosophy of mathematics. Am I right, Fernando? Thank you. This is a new slide. I presented to Fernando before because I'm not a philosopher of mathematics. He said, okay, you can use it. Yes. And some cultured French mathematicians, you know. Observe this. Events and possible words of Boolean algebras and their homomorphism in 0, 1 live in symbiosis. This was also hinted deeply by Fernando. By fixing the algebra, you fix all the possible words, all the homomorphisms. And by fixing the homomorphism, you fix the relation between the elements, because in the Boolean algebra, you see all the relation, whether an event is a negation, or whether an event is a conjunction of two events, or a disjunction, which can be defined by conjunction, as you know. And now we define inconsistency. We have defined event and possible word, and now we can define inconsistency. Only now, no hand waving. In logic, and more generally, according to Boole, in probability. Boole did not give the definition of inconsistency in probability, a la definitive. Today, you will see this definition, which is powerful, brilliant, and helps us to understand in other logic what may happen. Here it is. This is a young definitive, 1932, when he published in France, by the way, Poincaré Institute, his main paper on the subject. The definition of inconsistency now, I can give it rigorously. A book, which is a map from events in a Boolean algebra and probabilities, elements of the unit interval, the full unit interval, okay, is inconsistent if the vector, the root vector, can devise how to buy, how to sell tickets. The vector can divide stakes, and one and k. Different stake for each ticket, for each event, sorry, such that the balance, which we have defined before, the sum over the stakes multiplied the value of the book on that event minus the truth value, W of the event, for the possible word, homomorphism, W. Now everything's clear. Imprecisely speaking, unwavering, a book is inconsistent if a vector, a clever vector, can ruin the bookmaker. Okay, the definition is about this is a posteriori, after you have digested, together with your lunch today, this rigorous definition. I could write this because it's a precious definition. In books about definitives, sometimes you find events are not defined, possible words are not defined, and this thing is not defined. And let's speak of consistency, unwavering. The disaster of the fortune of definitive. So,
why do you need the ends? Shouldn't it be only 0, 1 or minus?
What do I need? What?
The end, the stakes.
Yes, I had to say how much betting puts money, okay? Betting is putting 1 million reais. In which way? Since each ticket promises 1 real, to express the fact that betting can bet any sum, I put it under the form of buying or selling any number of tickets is the same. You see? And the stake is the money she puts. I define the stake as the number of tickets she buys or sells. Is it clear?
Yeah. Well, you can always multiply by something. It's negative.
It's not necessary, but I had to show the beautiful ticket prepared in Bookie's lottery. Without tickets, I couldn't well explain the money you put on event. The number ticket to buy, each ticket promises 1 real, and you pay the probability posted by the bookmaker. Okay, that's the reason. So, in good books, you find the real numbers here. The amount of money could be not a multiple, but this definition is good. Okay, I hope I answered your question. Yes, it is just to show the ticket, didactic. Okay, now having defined, now we are going slowly. We have just defined inconsistency. Note, you know other definitions of inconsistency. But now we will give legs to this definition to prove a deep theorem, which is something that will remain about inconsistency. This main tool is known as a state, which is not a stake. Stake is the number of tickets Betty buys or sells. State is a finite probability, finite value probability. Anyway, state. Here it is. Given a Boolean algebra A, and now we have a comfortable space where to live, a state of the Boolean algebra, terminology from quantum mechanics, orderly groups, from the 30s of the past century, a state is a function from the algebra into the unit interval that intuitively assigns probability to the events. Okay? formally, a state assigns values in 0, 1 to the elements, to all elements of the Boolean algebra, and satisfy the following two conditions. This is a fundamental notion. If you write it and bring it home, you will not miss anything. It will be good to go home with this state. The state of the unit element is 1, has value 1. So a state says the event which is sure, the unit element in the Boolean algebra, gets truth value, it's not a truth value, probability value 1. It's not probability. Probability I don't define. I will not define probability. Second, additivity for incompatibles. When you have the disjunction of two incompatible elements, what does it mean incompatible? We are in a Boolean algebra. A and B equal 0. We have 0 in a Boolean algebra. Whenever you have two incompatible events, the state evaluates their disjunction, A sub B, by the sum. Did I show you yesterday what Boole did when in his mind he had probability instead of logic? He only defined disjunction for incompatible events. Here we don't do that. We assume that a state does it, but we have good old disjunction. So a state is an operation which is addition precisely when the two events are incompatible. The first important property of a state is the monotonicity property. You know, in a Boolean algebra you have order. A smaller equal B, X smaller equal Y. What does it mean? X supremum Y equal Y. This is the way. Or X implies Y equal 1. You have order. In any Boolean algebra you have order. And every state, this will be used, so be patient, because this is a theorem of God. And this is its proof. 3 lines, which you could take a picture. With this definition of state, S of 1 equal 1, and S of the union of incompatibles equal the sum of the two, you have monotonicity. If A is smaller or equal than B, then S of A is smaller or equal than S of B. This is a consequence of this definition. Okay? The proof is there. It's a proof to take pictures or to meditate. We first take two incompatible elements, A and B and not A. These are incompatible because B or not A is already incompatible. You feel it, and then we sum them, apply Boole, and the state of these two incompatibles must be the sum, and then it turns out that S of B is bigger or equal to S of A. The monotonicity requires a 3-line rule. Take a picture. It will be used soon. That's why I gave a proof. Another methodological Fernandian remark. Symbols and proofs, and I am adding symbols and I'm giving a 3-line proof here, are added not to intimidate students. They are introduced to improve our language and to confirm our statements. States are monotonic. Prove it, otherwise I don't believe. Higher and higher level of statements confirmed by solid proofs at the lower levels allow the construction of the mathematical building, stable and reliable, in such a way that you can sell it, speak about it in any nation, at any language, stably over time. This is the proof of Pythagoras' theorem on the infinity of primes persisted for 2,500 years. The same. A child in Greece at the time of Pericles finds that if he went to a good school, for example, Plato school, 1 century later, perhaps a little bit more, learn the proof as you learned it at the university. The same words, the same group, forever. And this is the second, I'm sorry to be, I'm never made pedantic. Yes, I'm reproducing what I copied from a previous course, yes. Entering a straight leg. It will be used not in this course, so I should go on with this. Take a picture of this. Probability stands to logic as state stands to extremal state, which is homomorphism. It happens that an extremal state in the convex space of states, I say it and then I will prove, is a homomorphism. So there's such a deep relation. And this is a proportion. A stands to B as C stands to D. Proportions, elementary school. Proportions like this are a powerful method to understand analogies between analogies. And this man, Stefan Banach, was the one who said, I don't know if Fernando knows, many mathematicians are good to do analogies, but very few, you knew that. Can you go on? Very few mathematicians can make analogies between analogies. It takes Stefan Banach, one of the founders of functional analysis, to have this extremely deep and beautiful and emphatic, not emphatic, simpatico, nice statement. Another theorem. Oh,
That the previous slide.
this one?
Yeah, it's fundamental to compute with the probability.
Analogies between analogies. It's extremely interesting that the insight of Banach, a functional analyst, is pervasive in category theory, in artificial intelligence, in computer science, and in algebra, everywhere in mathematics. You must be able to, this analogy, I studied the other analogy, but they look the same. Analogies between analogies. That makes you an even better mathematician, or perhaps an even better philosopher of mathematics. When you discover that something that was found in this century is reproduced mutatis mutandis in this century. And the analogy there is the same as the analogy. It was mentioned somewhere, something, a similar situation. Anyway, this is pervasive in mathematics, perhaps better than definitive theorem, which is also a milestone in probability theory. Okay? Here is the theorem. Now that we have the definitions, I can state the theorem. If I stop myself by hand waving, I should hand wave it and say that consistency in the logical sense means that the vector cannot be ruined, that the bookmaker cannot be ruined. It means nothing. But stating that the following statements are equivalent, beta, the book, is inconsistent in the sense that Betty, let's not mention Betty, we say there are. Okay, Betty can find stakes that ruin booking in the following sense. Some stakes times beta of the event I minus WO for any homomorphism AI is less than 0. Ruin. And then, who asked extendability? Rodolfo. The second corner of the theorem comes to logic. This book, which was defined only for these 5 events, E1, E2, and the Boolean algebra, 5 million events. This book can be extended to a state, not a state, the state of the Boolean algebra. This is a wonderful extension theorem that characterizes a local property. Inconsistency of book is book. 5 events there as extendability to a state, which we will see soon in logic will be extendability to a truth valuation, which is the classical consistency or inconsistency. So again, the consistency, which is a local property of a book, which is an assignment of odding bets, not probability. Probability is born here. A book is inconsistent if it is not extendable to a state of the algebra.
Daniele, in the previous definition of inconsistent, the expression was lesser than zero.
Yes, I hinted that mine smaller than zero is now. Are you asking this?
Yes.
Yeah, smaller than zero, since there are only finitely many, is the same as smaller than minus one.
Okay.
It's equivalent. I hinted that less than zero means ruin. It could be less than 1 zillion. Okay, if you wish, it's a subtle point. If you like, put zero instead of minus one.
Okay.
It's the same.
Thank you.
There is a, yeah. But anyway, you're right. I should have put zero because there's no reason to insist on minus 1 zillion when it is lost in any case. Very good question. Technical question. Again, on local property, the inconsistency, the definite inconsistency of a book assigned to a group is equivalent to a global extension property. You turn it, if A is equivalent to B, not A is equivalent to not B. A casa mia, at home. A casa mia. And again, you have beta is
Not a casa para consistente.
Nostra casa per todo. I told you I'm classical, like book you makes money with Daniel. This is classical, you're right, perfectly right. In this course, A equivalent B is the same as saying not A equivalent not B, because we have classical negation. Please. I explain why, okay?
Not a casa nostra.
No casa vostra. Okay? So the other formulation, consistency means extendability to a state, which at the logical level, consistency will be extendability to a true valuation, which is the classical definition. I will insist on going down now from probability to logic, because this course is about logic. Probability was used as a pretext. Okay? Explanation. So let's repeat a state, this new notion that you probably never heard of. A state is normalized in the sense that give 1 to 1. The 1 of the Boolean algebra is sent to the 1 of the unity interval, which is additive, as Boole wanted, on disjunction of incompatibles. Tarski and Kelly called states finitely additive probability measures. They want to put the name probability, and they want to insist about finite additivity. Right. But I prefer to say state. Remember the monotonicity property of states. Now we are able to say why this book is inconsistent. Only now. Before, we could only hand wave. So, in Rio, 0.5. In Copacabana, 0.58, which is more restrictive. Should be less than 0.5. The probability that tomorrow rains in Copacabana should be less or equal to the probability that it rains in Rio, because it could rain in Rio, Galeão, or far, but not in Copacabana. Okay? A more restricted event should have a smaller probability by monotony. Now we have monotony. So, am I hand waving here? Let's see. The second event is more restrictive than the first. So in the Boolean algebra, the second event is smaller or equal to the first. States are monotonic. States should give smaller probability to the second event than the first. So this book is not extendable to a state because it is not monotonic. So, by definitive theorem, this book is inconsistent. Well, you may say, well, I knew it before definitive. No. You may say you know it by assuming as axiom the additivity on incompatibles. But why, should ask Hilbert. And the explanation is here. Inconsistency means extendability to a state, but states are monotonic. This is not monotonic. It cannot be extended to a state because the state would be monotonic. But you are not monotonic already with these two elements. So you are inconsistent. The same for this about incompatible exhaustive event. The state gives 1 to the total event and is additive on incompatible, so it should give B1 here. So this book is not extendable to a state, so it is inconsistent by definitive. Yes. Well, methodologically, the additivity axiom is now a consequence of a theorem. It is theorem and its characterization be consistency. When an axiom becomes a consequence of something, that something is deeper than the axiom. And the less axiom you have, the best. This is mathematics. The effort of mathematics to have few axioms and derive the rest from few axioms. Where is the logic? I have been doing probability. The special case of 0-1 valued betting odds. The Pope will step down next year. Truth value 0. This is Holy Bookie who posts probabilities in 0-1. So posts truth values, expected truth values. And we will handle them by the definitive consistency theorem. The world economy will collapse before September. 0. Not true. Brazil will win. It was quoted also by me yesterday, by you this morning. Brazil will win, or we hope that Brazil will win the next World Cup. And we will have peace next year. These are betting odds published by Bookie. They are the same as probabilistic, only that they are in 0 or 1. 0 or 1. Formulas. And what is the strategy to show inconsistency? It is written here. I will buy 1 zillion of tickets whose truth value is 0. I pay nothing. Truth value is 0. What is the truth value? How much you pay now to win if the event occurs, €1. Okay, buy 1 million of this. They are free. And I will sell at the price of 1 zillion, the ones to which book is given truth value 1. And then if you meditate a little bit, if this book is inconsistent, I will gain a lot of money. If it's not inconsistent, no. Corollary. Given events with assignment in 0, 1, so logical assignments, the following conditions are equivalent. The assignment sends Bookie to bankruptcy. The assignment is consistent in the classical sense. So we are recovering consistency and inconsistency from definitive theorem. Consistency and inconsistency as sending the bookmaker to bankrupt. Another example, many events. The strategy is simple. Buy tickets which are free, those with truth value 0, you pay nothing. Sell ticket with truth value 1. That's triviality. Note that inconsistency has now a new equivalent characterization, which is quantitative, operational, it has to do with transactions of money, explosion free, so we are not in the main stream here. We are in the classical stream, and extremely flexible because it may be extended to many other logic. It has been extended to many other logic. Again, let me repeat, this is definitive theorem, and this is the logical subset of the theorem, recovering classical inconsistency by an operational quantitative exclusion-free definition. Again,
excuse me, is it also negation-free? It's negation-free, isn't it?
in which sense?
I mean, there's no negation.
That's no negation. That makes it flexible to logic, yes, without negation. You must ask your algebra to have a state, the notion of a state, and then you try to prove it, yes.
So that's why.
There's no mention, you're right.
Yeah.
I've never noticed that it's negation-free.
Yeah, so that's a good example of something which makes a distinction between non-contradictoriness and consistency. Or
And inconsistency.
Yeah, that's interesting. Yeah, that's
We
very
speak about inconsistency without negation.
Sure. I never thought, I know it's flexible, it's good for many logic, but I never thought that it doesn't use negation. Yeah, thanks for this remark. Invulnerability to sure bankruptcy caused by Betty shrewd bet is equivalent to extendability of the book to a state or to a truth valuation of the algebra of events and their possible words, which is built in the algebra. Before we have the probabilistic, and here we have the logic. It's the same, a subset anyway. Okay? A remark about terminology, solicited by Walter. Definitive inconsistency theorem, which I gave you 5 minutes ago, is well known as definitive Dutch book theorem. This is part of definitive's misfortune in its translations by the English-speaking people. It has nothing to do with Dutch insurance companies in the Middle Ages. We try to make money whatever the occurrence of it. It's irrespective of Dutch people, because if the case, the companies that made more money were British, English, not Dutch. And it does not understand the theorem, because in the theorem, if you remember, it is the better, it is Betty who tries to ruin the lottery owner. You see, it's not the insurance that tries to ruin the ship owner. It is the better, the ship owner, that tries to ruin the insurance company. It has nothing to do with Dutch insurance companies and with Dutch rules. This happened because they put names as they like without knowing the theorem, without being able to prove it, without able to state it.
Also, may I suggest we change it to the Fox book theorem? Everyone will understand it.
Okay. What about consistency theorem? it's a consistency theorem. I called it definite consistency. Yes. When I submit papers with this terminology saying that it's wrong, that in Italian consistency is coerenza, but they would translate coherence wrongly, they mumble, but this is the reality, so they publish. It's terrible. There are many examples of definite misfortune. I'm trying to revenge it in a sense. It was a really great, he was a successful mathematician, absolutely. He was not hidden or forgotten. But he had a misfortune from the literary viewpoint. Given that states are finally additive, you remember the definition, are you, DM, restricting to finitely additive probability, while Kolmogorov, of course, successfully did countedly additive probability? This is a first objection. Oh, they are doing Bayesian, finitely additive, subjectivist, blah, blah, blah. Probably. No. We are doing full-fledged Kolmogorov probability. And now, entering a straight leg, close your eyes, those who don't want to see a deep theorem, because I will not explain it, but just to say that no, we are not doing subjective, Bayesian, finitely additive, children-like probability. No, we are doing Kolmogorov in its full force. Okay? Yeah. Stretching leg, Stone-Kara-Theodori theorem, my stone, which will be extended later on to full Kolmogorov. The states of any Boolean algebras form a convex compact set that is the same, a finite homeomorphic to the set of regular Borel probability, which are countably additive, regular Borel probability measured on the stone dual by stone category theorem. The stone dual of the Boolean algebra. The state of the Boolean algebra are the same, which are finitely additive, are algebraic objects, are the same modulo extension, they are the same, but modulo and affine homeomorphism. Homeomorphism means topological identification. Affine means that it respects the algebra, so they are the same, with the countably additive regular Borel probability measure on the dual stone space of the Boolean algebra. Here you see, if not anything, the power of algebra, because you have Boolean algebra with its famous, but less famous is nothing fundamental. It helps us to understand. We are not doing finitely additive probability. We are doing modulo Stone and Kara-Theodori, which proves the extension theorem. We are doing full-fledged Kolmogorov probability. So it seems we put nothing, well, except this leg stretching thing, yeah? Which I cannot prove here because it would deviate from the style and the aim, the design of my course. But I want to give it to you to show that we are not doing finitely additive subjective probability. So logic as a subset of probability are together as the two faces as Boole felt and insisted and, in a sense, argued for. It is here again. Remember, I gave it yesterday. It's the design of my investigation, so you remember it. Putting together logic and probability because we have the same artifacts in making computation. And this will help us to understand here artificial intelligence, a sense of the ambitious.
This is the laws of thought.
Yes, this is chapter 1, page 1, section 1 of the investigation. You were not here because you arrived later. I gave it earlier. This is chapter 1, page 1, section 1. So what we are doing in this investigation of the human.
I know only chapter 10 and 11. Which are
because artificial intelligence people don't read the introduction. They don't need that. Well, I was in computer science 15 years in Milan. You would skip all introduction. Yes. Well, I want now to give you 3 applications, hoping that they show the power of this theorem. Well, I gave before the Stone-Kara-Theodori, but with blind eyes because I cannot prove it. I want to insist on 3 applications to show the power of this theorem. In probability, you have incompatibility, you have Boolean algebras, sigma Boolean algebra when you want to do it countably additive, and you have independence. It's a deep notion of independence on which probability is based. But observe a very cute, intelligent, deep probabilist, Kak. What does he say? Let's read it together. Take a picture if you don't want to read, but it's so refreshing. There is independence in the narrow but well-defined sense that the rule of multiplication, you remember Hilbert, of probability is applicable. The rule of multiplication, so it defines independence. It was the vague and intuitive notion that provided for a long time the main motivation and driving force behind probability theorem. And while an impressive formalism was being created with this definition via the product law, mathematicians, with very few exceptions, always remained aloof. Because it was not clear to them what the objects were to which the formalism was applicable. Well, what could happen worse than this? You don't know what the objects are to which the formalism is applied. About independence, which is a main ingredient of probability. Suppose in logic you write, for a long time there was a notion of consequence, but many remained aloof because they did not understand it. Gosh, you're doing logic. You see, and Markov states this. Because independence, indeed, is a crucial notion in probability, which is defined by the multiplicative law, which is a definition, whereas incompatibility is an axiom. That's why Hilbert did not feel at ease. I insist on this again. The probability of the disjunction is the sum, blah, blah, blah. The probability of independence is the product of their probabilities. At present, the development of probability has that axioms and definitions somewhat overlap. Not good. Why should independence require probability, given that it is an entirely logical notion? You don't believe? You must believe, because look here. The next pope will be Brazilian. France will win the next World
You are
Cup.
very provocative.
Yeah.
You are very provocative.
Italy will be able to play.
Our history is so terrible. And let me do my course. Yes, I suffered when Italy won the European Cup, by the way, beating England, you know. Oh, wonderful. Last penalty, and then we collapsed, and we didn't even go to Qatar. They say they objected to the Qatar. No, they were just the poorest. But let's not speak soccer or football, because it somewhat deviates from what I wanted to do. Or we may. This was just to show that popes and football are an independent notion. Where
No, but there is a problem between Argentinians and Brazilians. You are provoking.
they vote against, they vote against.
But this time, all Brazil was with Argentina at the end of the cup. Okay? That was a miracle.
Against Europe. Against Europe.
Against Europe. Against Europe. Okay?
Well, I wanted to show two independent events in some my course is collapsing. Well, let's change it. The next book will be of San Marino. You know, but it's zero. San Marino has 20,000 inhabitants. There are no priests. No, you must believe in the independence of this. I don't see connections anyway. I use different examples, but here in Brazil, I wanted to put some Argentina.
That's fine.
They are independent. Are they independent? Rodolfo, are they independent? Who doesn't mean they're independent? Raise them, please, and then go. These are two independent events. Without assigning probability, except Italy probably will say the next pope will be presented 0.9. No, note, we have independence without going to probability. You see, because it's a logical notion. May I go on with my course? May I go on? They are independent. Say they are independent.
We agree, we believe that.
Say it with a mental reservation, Jesuitic, again. They are independent for you, Daniele. They are independent. Basta. They are obviously independent. Even if no probability is assigned to them. So, what is this product law of independent, if we can say they are independent without giving probabilities? Independence is basically a logical notion. Why should independence require probability? Given that it is a probability-free logical notion with a natural, classical definition, which I will give now. So not only hand-waving logic, but there is a definition of independence in logic. So you have to apply this definition to prove that the independence law for the product follows from the definitive theorem. Very little problem, okay? Now let's go. Two events are independent if there is no logical, I will explain this. Now it's hand-waving, okay? No logical relation between them. But the usual definition of independence is not stated in logical terms. It requires a probability, and it says the product law. The usual definition, in fact, states two events are independent if the probability of their conjunction is the product of the probabilities of the two events. It's curious, isn't it? Why do we need P, the probability? Why do we need product? Why product comes in here? To state the independence of the following clearly independent events. Two subsets, and this is the definition, by the way. You can take a picture because it's order. Two subsets in a Boolean algebra, again Boolean algebra help to understand, are independent if whenever you take an event in the first, another event in the end, and the intersection is non-zero, so both are, no, and they are non-zero, they are never disjoint. The intersection is non-zero, so they are never, when two elements are non-zero, the intersection is non-zero. It could happen that two elements are non-zero and the intersection is zero when they are incompatible. But independence prevents it. Again, two subsets of Boolean algebras are independent if any element of the first, non-zero, and any element of the other, non-zero, you take the intersection, you are non-zero. Tarsk, Kelly, Horn, Sikorsky. Intuitively, the independence of the two events means that, remember this, the occurrence or non-occurrence of the first event has no effect on the occurrence or non-occurrence of the second event, intuitively. But I gave the formal definition before. Now close your eyes again, because this is just for you to remember when you are sleeping tonight. Yeah? And I spoke Brazilian, then independent. You see, there is place for any combination. Forget about this.
Sorry, Daniele, in the previous slide, you meant intersection or conjunction?
What did
Or
I
the meet, I mean. In the previous slide, you said intersection.
Whenever,
But you wrote the sign of, look like meet or conjunction. Is that intersection and sign and?
whenever
yeah.
both of them, M and N, are non-zero, their conjunction, their and is non-zero.
Oh, you said
The meaning.
intersection, okay.
Sorry, I was thinking of slow representation as said. I'm very sorry. Very conjunction. I mean. Yes. Thank you for the correction. Okay. Forget about this. Now, theorem. After discussing with the referees about terminology, misfortune, and so on, product preserves the consistency in the definitive sense of two books on independent events. So, if Bookie has a book for horse races and a book for football matches and uses the product to combine the probability of conjunction between who wins a horse race and who wins the soccer, then he is consistent. If his book was consistent, applying the product law, he remains consistent. Second result, product is the only operation that preserves consistency. So product comes from definitive theorem as a consequence. The product law is in the definition of conjunctions of independent events, becomes a consequence of definitive consistency notion. So the addition law for incompatibles is a consequence. The product law for independence is a consequence. So it's a theorem, it goes to the root of probability. And it is not finitely additive probability. So this bold man is now happy. It seems that the confusion does not exist anymore. There is a deeper fact that explains what is an axiom, what is a corollary. Both are consequences of this deep fact. This was 1905, definitive was 1932, and the papers I show you were last year or 3 years ago. So, Holy Bookie, our friend, says, oh, should I stop here?
Yeah.
Well, let me just show how it should sell consistent bets. So Holy Book now, in the light of this theorem, asks, how should I sell consistent bets on independent event, soccer and football, for instance? Let's see. Now we have soccer, football, in Japan and in South America and Central America. And Bookie asks, look, I gave honest betting of the sum is 1, they are incompatible, if you sum, it's correct. But the problem is that I want also to have bets on conjunctions of events. For instance, Tokyo wins and Mexico wins. How much should I give? How much should I give? You see, then the old tradition say you must take products because they are independent. Yeah, they are independent because when you do the Boolean algebra, you discover that whenever two are non-zero, their conjunction is non-zero. This is the reason, and so product is the only possibility to preserve consistency. This is the solution. Look, where is the product? Product is the only operation that always preserves consistency in the definitive sense. And then we have the independence law as a consequence of it. Yes, thank you very much.
Is there any question or do you prefer to wait for Professor Fernando Salamea? So,
No, it's not a question, excuse me. It's a comment, but it's a comment that I think it's enlightening for the young students here. I know it will be strange for Professor Daniele Mundici, but it's a comment on here. I think it's important for the young people here. Today, Professor Mundici talked about some of the great names of mathematics in the 20th century. Banach came from Boole, and then Cat and Definetti, and people really looking at several things at the same time. In my course last week, I tried to show you that the most important concepts in modern and contemporary mathematics are mixed use. So I want to show you very briefly, in 2 to 3 minutes, why Professor Daniele Mundici is not only this fantastic professor, very, very worried about that. Most of you will understand that it's one of the greatest decisions of the last 40 years. It's simple. Mathematical logic in the 20th century has had like 4 big areas: model theory, proof theory, set theory, and non-classical logics. So a person who has been able to work on all that is a person who will have a good sense of the mixture of the things in mathematical logic. So Professor Mundici began to work on abstract model theory. Yesterday, Professor Dragalina showed us the importance of abstract model theory to produce a kind of transitory ontology. He was one of the main specialists on those things in the 1980s. And at the same time, working on this very abstract model theory, which is kind of looking very deeply onto the structures, he was able to look at the proof systems. He was also a specialist on computability and proof systems in those times. And then also he continued in this quest, this constant quest, and he became one of the specialists in the world on algebraic logic. Another mixture, very important mixture that comes everywhere. So the mixture of abstract model theory, the mixture of this computability, proof theory, the mixture of algebraic logic, and then he became again a specialist in the world on many various logics. Understanding these kind of things, which go deeply into the real Banach and the real functional analysis, C-star algebras, things which are very, very important in mathematics, and which provide logic a lot of understanding of what is happening. So there is a strong mathematics, and good, extremely strong mathematics in the mixtures that Professor Mundici has done in the last 40 years. I want you to know that, because he's very modest, very simple, and very emotional by that. Extremely modest, so as a brilliant man should be. A brilliant man should never be talking about himself. Never talking about himself. It's something makes me a lot professional.
I rewrote my course after attending yours. I can only say that. Rewrote.
I'm worried about time.